Thank you, Joe, for the introduction. So, in the next, let's say, 45 minutes, I will be talking about practical understanding of Zowe API Mediation Layer and Zowe CLI, which are both components, as you know, of Zowe open source project. I'm a first-time attendee of Db2, and actually a first-time attendee. Thank you very much, and actually a first-time attendee of any kind of conference like this. So bear with me. I will do my best. I prepared, so don't worry. So the agenda, I will split the presentation into two sections. First will be about mediation layer, a little bit longer than CLI, because that's much more closer to me. And I will be speaking about introduction architecture. I will be emphasizing the fact that we have to continue build the content for Zowe and how to do that, and then I will show you a simple dashboard application which will be using REST API of ACSU for Db2 product at the back. Then I'm gonna switch to CLI, intro and architecture, and then I will show you how to easily put together a test automation use case using Zowe CLI Db2 plugin at the back. And then I will finalize with some useful information links about the open source. So, quick introduction. Mediation layer pretty much is sharing the vision with the rest of the Zowe, which is to create a something like an abstraction layer on top of the mainframe complexity, so that it's much more attractive to the out-of-university graduates and top talents. As you know, many of our senior colleagues or very experienced colleagues are soon to be retiring, and so I think Zowe is not about removing the need of having such experts, but to perhaps challenge every situation we have by creating the new automation using this technology and maybe the more modern stack and highest level languages as possible. So what's the role of mediation layer in all of this? I think this project started even before it was contributed to Zowe as a solution to consumption of very diverse implementation of REST APIs among the mainframe platform. So over the years, obviously API, the concept of API exists as long as two applications wanted to communicate with each other. But it's maybe just a 12 or 15 years when we started to build REST API services. And at that time, our colleagues used the technology which was available at that point in time for very specific use cases for their product teams. And so this led into certain diversity. So mediation layer is here to maybe standardize the consumption and consumption of the security. And with moving towards the Zowe and open source, let's say the positioning of this technology changed a little bit to be a consumption of infrastructure APIs on mainframe platform. At this point, I'd like to point you to this article, blog and white paper, which was written by Sujay Solomon. At some point in time, Sujay works for the Zowe community as well, and community felt like we have to maybe provide a clear statement for the positioning of this technology, because we were asked quite a lot that, you know, but there is this API layer 7 from CA Broadcom. There are other tools like ZOS Connect from IBM. There is even APG from Google, which is, and all of them are much more mature technologies. And so this technology is really about consuming infrastructure APIs, which are meant for DevOps, automation, for example, or if you want to build a in-house dashboard application for operators. Imagine, I don't know, you want to continuously check the health of the LPAR or something like that. as opposed to business logic APIs, which are more for end user consumption in the form of, I don't know, some web applications. About the architecture, if you ever wandered around Zowe.org website and tried to download Zowe, you're going to be presented with two packages. First is called Zowe Components, and second is CLI. So CLI is obviously that's for PC consumption, and then you have the Zowe Components. Mediation layer is part of the Zowe Components. As such, it runs on mainframe. It's a Java application, and so it runs under Unix system services in Java virtual machine. This is a diagram of the architecture. Mediation layer is the blue squared area over here. It has 3 major components plus one slightly smaller. So the first one is API Gateway. API Gateway is the single secure point of entry. It receives all of the incoming requests from the client applications and hides the complexity of the variety of APIs at the bottom. Then we have a discovery service, which is just a system registry or service registry. It contains service detail information about these services. Stuff like where, for example, documentation is located, what's the service ID. I'm going to get to that. And the third one is API catalog. And it's just graphical representation of those APIs running through this system. At the very top, you have the user REST API client. It can be a web browser or some kind of automation or application. At the bottom, you have the Zowe products and their corresponding REST API services. So how it works is that the service at the startup will dynamically register itself with discovery service. It sends a configuration metadata to this service, and then discovery service is then responsible for sharing this data among the other components. So it's going to send it to gateway so that you know what service ID should be used, for example, and then it sends to the catalog so that the data is visualized. In between REST API service and the discovery service, there is a heartbeat implemented so that you can see also the latest status of the service, whether it's up or down. So this is the architecture. You can also see that some of the components are scaled. It's called high availability mode, and it's currently not available in Zowe, but we have this in roadmap to kind of implement that. It's more about documentation and some configuration files to do that. It uses a Supak distributor so that perhaps you can have one gateway on one LPAR, second gateway, which is actually the same, just for sake of high availability. You're going to have it on LPAR 2, etc. Same for a discovery service. One of the key benefits is obviously it's a security consumption. Layer is not trying to be a security provider. It communicates essentially with the security domain products on mainframe. For that, you have in catalog, you have the gateway, REST API services, description of endpoints, which can be used by services which are trying to communicate with the gateway, as well as it can be used for SSO solution. This was implemented already. Example of routing through the gateway. You can see that there is a URL number 1. It represents certain service, API service 1 on port 1. And there is another service, which is API service 2, port 2. You can see that both are running at the different port, a different URL. And after the routing, the host name part and the port will be the same. And this seems to be a pretty big thing for a network administrator to just, instead of, I don't know, 50, if there are so many REST APIs there, to just, set just one one URL or base URL to be exposed. Yeah. A couple of words about Zowe Conformance. It's a program for two kind of group of users or personas. First one, it's for Zowe users or ISVs, SVs who just want to leverage the content in Zowe and want a certain confidence that when they deploy these applications into the production environments, that they will behave as expected. And it's also for developers who want to keep extending mediation layer or other components and want a set of guidance so that eventually they will get a conformance mark. Example of such criteria for mediation layer is already mentioned the dynamic registration, which is the preferred option, versus the static definition, which is a minimum requirement. And then the service has to accept the basic authentication, which is the minimum requirement, and as well to accept the token in the cookie, which would be preferred. And other examples are the published service URL follows the gateway conventions, that there is a documentation in the form of Open API 2.0, and others, and for example, that the request and response payloads are in JSON format. JSON format, because of it's very easily to programmatically be exploited by other high-level languages. One of them, for example, Python, or obviously a Java. This is a snippet from Zowe marketplace or market space. This is a cardboard which is showing current conformant REST API services. At the top you can see conformant services for mediation layer, then for Zowe application framework, and for CLI. You can see that Rocket IBM and CA already contributed some content, as well as the Phoenix software. So now, what tools are available for building such content for mediation layer? So we have a REST API Service SDK, which is a very easy guide for someone who needs to or wants to build a new REST API service. I will have a separate slide for that. Then there is a static definition, which is very handy for teams who just don't have a capacity or are not allowed by product management to do any changes in the code, so they would use the static definition. The way it works is just that the metadata you would dynamically send over to Discovery Service, you would put them somewhere in the dataset member so that Discovery Service can see it. And then plain Java integration enabler is a piece of code, jar file, which you would build together with your application so that you are integrated with mediation layer. It's not easy as it looks like. During the time, as I said, REST API implementation is pretty diverse, and some people have some configuration in JCL, some configuration in XML, and so this is the code which should for existing services to get them onboarded with mediation layer. We originally have something called Spring Boot enablers, but we feel like this is the better option to use the plain Java because it's much easier to customize. All of this information is available on Zowe.org if you go to the section developing for mediation layer. About the REST API Service SDK, it was built for sake of originally for sake of hackathon, which just happened in Prague. We had 39 teams contributing to this project, and I think today or tomorrow there should be some results. So hopefully we're going to have some real nice POCs, which eventually can grow into some conformant applications. The SDK consists of common library, development CLI tool, and the sample REST API service. Cool thing about the library is that It consists of examples of how the API logic should look like, how the error handling should be done, and on ZOS side, tricky things like, for example, a native calls to native libraries, some kind of assembler libraries on ZOS. So it's really like a vertical slice, and the guys who wrote it, the primary contributors of Mediation Layer and CLI, Dan Kelowski and Petr Plavenik, they created also a video which is like that you can really do it in 5 minutes. Person who doesn't understand so much about this is just a regular ZOS or sysproc who can really stand up this service, including the CI/CD pipeline, and as a result of that, he's going to have a sample REST API service integrated with Zowe with a very simple greeting endpoint which returns your name will be passed. So that's pretty cool. It's already available in open source. That's why we are doing it, so that it's available for public, and there are more and more services there. Going to the Zowe users, we talked about developing for API mediation layer, now about the users. So I mentioned that one of the use cases is to create a dashboard applications. So that's the system operator who would benefit from such application. This is a mainframe application developer. Internally we call her Michal, someone who is just out of university graduate, hates to go to the green screen ISPF and would like to use the modern tools which she used at the university. And then system administrator who is installing mediation layer Zowe, doing all the security setup, installing the REST API services as well. And there is a very good dynamic in between these two when using the mediation layer. Imagine that this person writes an application and perhaps it's not performing very well, so system admin would just stand up another, will scale up another resources or instances of the same mainframe product or REST API service, so that it's just so that the application is performing very well. I forgot to mention about load balancing capabilities of Netflix Zowe, but just would be awkward to go back. So, anyways, so I'm going to now show you the dashboard application, which is going to be using a sysview for Db2 REST API at the back, using a JavaScript, and it will be showing a health of a Db2 for ZOS. Yeah, so this is the catalog, this is the tile view. There is a ZOSMF management facility available, mediation layer, and now I'm searching for the Db2 data service API, which I can use for showing the performance statistics. I'm looking at the service detail information in the catalog. I can see that this API gives me the performance statistics. I'm just checking the host name and URL, which is it's the same as the catalog, which is great. It means that it's routing through the gateway. This is a JSON document or raw JSON response, which is great when you just want to develop and use static backend, so you can just use that JSON as you don't have to even touch mainframe. Anyways, there are multiple endpoints, and I will stop at this one, which returns short-term time series of critical Db2 metrics. This is the sample of the response. And then this is the application. It uses the same URL again, and there are some available fields I can choose to filter out. Yeah, just going through some options here. If you think that the application would be very difficult to write, this is a 250 lines of code of JavaScript, which can be really written by out-of-university graduate using those endpoints. So that was it. The use case for the sorry. Yeah. So going back to the presentation. Now the CLI. Part. So now imagine that you have the Zowe ecosystem full of APIs, infrastructure APIs, and you just need another way how to consume the content which is running through Zowe. And so for that, there is a client-side CLI that allows access to infrastructure services on ZOS. It enables developers and DevOps engineers to control, script, and develop on mainframe. It shares the same vision, which is to address the skills gap and to improve the delivery lifecycle. This is Michal again. You already know her. It's just a different picture of the same person. And so should have changed it. Doesn't matter. And this is Ravi, who is a DevOps engineer. So we have both of these people in our team who are developing the mediation layer, or who are the primary contributors to this project. And we used to have a CI/CD pipeline internally. Now everything is open and in Zowe. But just a sort of an example that the team is predominantly built from Java developers, but there are some mainframers. And when we had just this standalone version of mediation layer, we used to, every 2 weeks, to drop the new PTF to make it available for customers. And it was just a set of tasks which were not very fulfilling to do. And so every 2 weeks it was the same person who would generate the elements, go to the endeavor, and go to another stage, test, and all that, and then to publish. And I could see that this is going to be a problem if this person will leave for the vacation, and it actually happened. And so you would be amazed how these new guys, just who don't want to touch the ISPF, would be creative how to automate things like that. So this is just one of the examples which can be maybe interesting for you. Yeah. So Michal would like to consume mainframe resources as she would any other cloud platform, such as the AWS or Azure, using all of those tools. The command groups which are available in the basic package in Zowe are the ZOS files. You can work with datasets, create them, delete them. ZOS jobs to submit, retrieve results. And then a group of ZOS console, issue ZOS console commands, then you can issue TSO commands, you can do provisioning, and you can use ZOS workflows. So at the back of CLI, there is a ZOSMF API layer. ZOSMF is a product which is pre-installed with the operating system since, I think, version 2.3. After that, you have to do some security setup and some post-install configuration, but essentially it's there available. It is also used for generating the JWT token for the authentication, so that the security really remains with the platform. And so those are the workflows. It's a concept of let's say, perhaps the future of installation of products on mainframe. So like a next step from SMPE perhaps would be that you would have a catalog of portable packages, which are just like a snapshot of the CSI environment, and you would just paste it a couple times in your environment for your to speed up the development, and then you would use the post-install configuration workflows to finalize the setup and deploy. So that was the command groups, and then you have 3 plugins available in Zowe: Db2, Kix, and IMS. Little bit about imperative CLI framework. I'm not very knowledgeable to talk about this, but basics are that CLI guys really build this the architecture around CLI so that it's easier to extend it. And so if you go to Zowe again and developing for CLI, you would be prompted with a couple tutorials, and you can either extend the current command group, or you can create your own plugin using this imperative framework. So this is just to show you that it is fairly easy that there are tutorials and you can easily extend and create new plugins. This is a very cool thing provided by IBM. It's a Z trial environment, so you can for a couple days give it a go and try to extend Zowe API or application framework or Zowe CLI. And this is the test automation use case. I will again shoot a short video. Yep. It's running, I guess. Oh. Sorry, I dropped this thing. Can you hear me? Yes, I guess. Okay. Okay, so I'm looking at Zowe. I used Zowe Db2 command to check what is available in terms of this plugin, and there was an execute command. So DevOps engineer has a set of automation suites, and he's using test.bat file to do that. And as you can see, all of them successfully run, and the return code is 0. And so now I will be extending the same test file by adding a call to Zowe Db2 execute SQL query, and I want to insert the results into the Db2 database. So I'm going to execute the test db2.bat. Again, the tests are successfully finished, and I'm now saving the results to the database. And finally, I'm going to have a third bat file, which will retrieve the results from the Db2 table using a select statement. Everybody can see it. So, and these are the results. So that was it. That was the, let's say, not a final solution for Db2, just a showing you that you can actually connect these two worlds and do a simple insert and select statements to access the Db2 database. And we'll return to this. Okay, so just 2 more slides. A cool thing about open source is that if you want something, You can just ask for it. You can open up a issue with API layer or any other components, CLI, or there are many repositories against you can create issue. It's a funny thing, in GitHub everything is called issue. But yeah, such as same as in Star, everything is a problem, right? So anyways, and if you really want something, you can create a pull request and become one of the contributors. And I see this Zowe, the CLI guys also are giving a hint to the contributing guidelines, and perhaps the first that you can tackle some open issues, and they collected some first issues for you. We are also in Slack. If you search for Open Mainframe project on Slack, you can participate in the conversations. Also the calendar of all of the meetings, even for the development or for customers, is open, so you can be part of that. You can ask questions. It's very easy. And then finally, the resources. We released a couple interesting articles on medium.com/Zowe, so you can see stuff like, for example, how to write cleaner and safer ZOS code with Zowe CLI and SonarQube, or one of this one, which is using Zowe to display CPU consumption of a mainframe address space. So that was it. Thank you for your attention.